Hi, so welcome back to the fifth video in the series, and we've already seen as to within R there are different data sets which are available, and those data sets are as part of the data folders or the data directories of the various packages that we upload. And we've seen the package data sets, and yes, we've seen that it has got these various data sets. So how to upload one of these data sets? So what we basically do is we do a attach, and with that attach, we attach that database, that data set into our environment, and then we can use those, uh, you know, whatever is there within that database within our environment. We simply need to call them. So we need to focus. This means that the database is searched by R when evaluating a variable. So objects in the database can be accessed by simply giving their names. So we need to just mention the name of the object, and then we can go ahead and access it. And similarly detach. So once we are done with a particular data set, we can detach that data set, and we need not retain it for later. We don't have access to those objects anymore. Again, search can be used to search what is there within our environment. That's again a helper function. So this is what is there, and this we've already kind of seen as to how to access a particular vector. So we call it the data frames column vector, or one particular column of a data frame. And what we would also want to see is how do we access a particular say a row. So these are three ways of accessing a column. The way that we want to access a row is basically slicing. So let me look at this code. So it says print df underscore 1, and in the square brackets it says 2 comma. So 2 comma means the second row of all the columns, because after the column we've not mentioned anything. So there you have the second row printed for all the columns. And if I were to look at this within my console, that is what it is. So it says the product name is this, the product ID, the date of invoice. Now we can also go ahead and assign this to a temporary data frame, and then we can print out that data frame and see what is there. So if you print out this particular data frame, we see that this data frame has taken only that second row with values from each and every column. And again, if we were to go ahead and view this particular data frame, so we see, yes, it is there. It's a data frame of only one row and as many columns as were there in the, let's say, the parent data frame from which we created this. Now, if we were to go ahead and see a summary of this, then again what we'll get to see is that summary function basically considers all the values which are available within the parent data frame, and whatever came into this one particular slice, for that it gives a 1 or a true, so to say, saying that yes, this value exists under the product ID, under the product name. And for the ones which do not exist, it gives us a 0. So over here for 3rd January and 4th January it gives us a 0. Over here for 2nd January it gives us a 0. And date of invoice within the within the parent data frame could have only two values, 1st Jan and 2nd Jan. And date of shipping had three values, 2nd, 3rd and 4th. So this is how it is. So by running the summary on a slice from a data frame, we get to find out as to what parts were sliced and what parts were not. Again, now what we can do is, here we've gone ahead and taken either one row with each and every column, or earlier what we had done was we were looking at one column vector. Now we can go ahead and provide multiple columns or column vectors to this particular slice. And how do we do that? We do that using the combine function. So we get three column vectors over here. The one which is number 2, that is product name, then number 4 which is date of invoice, and number 6 which is cost price. Okay, now moving ahead, let's further look at what we can do with. Okay, so let's create a new directory. So how does R allow you from within the command line of R, or within this R markdown or R script or the console, to create a new directory structure, so, or create a new folder? So this is the command for that. What I'll do is I'll go ahead and first delete that. I have here already intro 2. I've deleted this and I just have intro 1, and we'll go ahead and run this one line of code, and that one particular directory or folder will be created over there. Okay, so that's how simple it is. But for now I'll just comment this out in case you want to run it. You change the path to what is your path of your current working directory, and then you go ahead and we've already seen how to get working directory and those things that we've done earlier. So that is one thing. So plots and graphs within R can be very, very complex, also can be very high level or say high dimensional and things to that effect, or they can be pretty simple also. So what we'll look at initially will be very, very simple graphs and plots, which are more of value to a statistician than are to somebody who's doing maybe some kind of social network analysis or something of that sort. So there's pretty complex graphs also. I've done a couple of videos earlier on social network analysis, which you can see, you can refer on my YouTube. And of course, there's a whole lot of other things like Neo4j, the graph database, which also interfaces with R and with Python and with other, whole lots of things are there for plotting and graphing. There's Plotly, there is d3.js, there's lots of JavaScript libraries which are there, high charts, or then there is also lots of charting options with R, starting off with ggplot2 and RAM charts, and God knows, there's no end to it. There's so many of them. We start off with the basics and understanding as to why something happens in a certain manner. So if we were to execute the code from the following sections in the console, the graphs would not appear in line, that is not in line within the R markdown, but would appear with the plots pane. So that we've already kind of seen how that happens. Now quickly going to the histogram, and you can estimate, so histogram is basically the estimate of the probability distribution of a continuous variable, which is a quantitative variable or continuous variable. So you cannot have the probability distribution of a non-continuous variable with a histogram, or a variable which is a factor. So you can't necessarily have a probability distribution or PDF for a non-continuous distribution, is what is my understanding as of now. We'll see if that is possible later on. So firstly, creating a histogram, a basic one. This is what we get, and what I'll do is I'll also run that code specifically within the console so that we can see those graphs here. Here it is. So the histogram for cost price. So what is the frequency? So the maximum number of cost prices, that is almost 8 or 8.5 or 9 of them, lie within the range of 0 to 50. So let's actually go and see if this is correct, or how these bins are created. So this is the probability distribution. So okay, We want to look at that particular, while we also want to, so quickly whatever is coming out, just um, call it hist1 and just save it there so it pops up. And while we can minimize this, and then we can go and look at that data frame. So which data frame is this that we have plotted? This is df underscore 1 and cost price. So df underscore 1 and cost price over here. Okay, so the values of cost price, we want to see how many are below 50. So the best is to see this df, so we can also click over here in place of just writing that view and going to the cost price column. Cost price, here it is. Let me sort this cost price column and I'll get to see 1 2 3 4 5 6 7 8 9 10 11, almost 11 values below 60. So what is it showing me over here? It is showing me in this histogram PDF file, it is showing me that below 50 there should be around 9 values. So below 50 I have counted 11, below 60, and below 50 1 2 3 4 5 6 7 8 9, exactly, perfectly fine. So these 40 upwards, 40.176 upwards, just look at the cost price column, don't look at any other column. We have 9 values. Okay, and because we have these 9 values, these are the values which have been shown over here. So these 9 values lie within this first bin. So that frequency is basically showing us as to how many values are there, and this is between what range? So 0 to 50 range of cost price. Then again 50 to 100, it is showing us exactly 6 values. So let's see whether 50 to 100 there are 6 values. So 56 will be considered. Yes, 1 2 3 4 5 and 6. Perfect. So there are 6 values. So 56.120 comes twice, and right up to 97.360. So we can see that there are 6 values within 50 to 100, which is perfectly fine. And between 100 and 150, so there should be only one value between 100 and 150, which is again correct, absolutely correct. We just have 132.640. Then the next bin, we have 150 to 200, and there are 2 values shown. So 150 to 200, again absolutely correct. So wonderful. So this histogram works. Yeah, okay, so I was just doing that to make us understand as to what exactly the histogram is and how does it basically give us this fancy looking plot. Okay, so what I'll do is I will I can't seem to do what I wanted to, but I will probably end up doing this. So this is the histogram that we are getting, and I have kind of explained this now, and I can now close this file. So I was trying to do something, but that's not happening any which ways. Let's leave that alone. So the next histogram is of sales price, and I have gone ahead and created that in orange color. Figure margins are too large, so we need to kind of enlarge this and again run that line of code there. So this is the sales price. Now again saving a PDF so that we can see it separately. and calling it hist2, and going here and again looking at the sales price. Firstly, we saw the cost price. Now we are looking at the sales price and again sorting it out. Okay. Now 0 to 500, how many values? We've got 15 values between 0 to 500. So that's a very large bin. Now, how come we have such a large bin suddenly? Why we have such a large bin is because the values are stretched out, so to say, or are falling over a very wide range, starting right from 0 to 2500. If these values were from 0 to 1000, then we would again get bins which had much tighter values, so to say. So that is not the case over here. So let's say let's quickly count these 15 values and see whether they actually are like that for sales price. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, so 13 values I can see below 150 only. 13, 14, 15. Perfect. Perfect. So 16 values are there which are seen below 500. Perfect. So this is 15 is here and this is probably 16. Excellent. So this is exactly correct. And so we have this histogram of sales price. So we have basically understood the concept that we are trying to chase over here. And coming back to the markdown. Okay. Now further. So these are two histograms that we've created, and those two histograms, like we saw, were part of two different plots. So those two different plots we got to save as two different PDF files, and we could refer to them separately. Now we look at the par function. So this par function is not part of the base library. That's the reason I've gone ahead and I've kind of highlighted that over here. This par is part of the graphics library, and the next sections we look at some basic usage of the par function. With it we can create matrix of n rows into n columns of various plots and graphs. So we are not creating a matrix of numbers or a matrix of characters or something of that sort. We are creating a matrix of graphs. So within one particular plot we'll have more than one graph. So let's consider one histogram up here to be one graph, and this again to be another graph. So we'll have more than one graph in one particular plot area. And how we'll do that is we will define par in this manner, wherein we will say that the MF row, the matrix filled, that is MF means the matrix filled row wise, will have two graphs in the first row and one graph, will have two rows and one column filled in by rows, or we may use MF column to fill by columns. So we are not going to do that. So we're just filling by rows over here. And so this we have gone ahead and done. And now we are again getting those two histograms. And let's see how this gets plotted. Let's run this code over here. Again, that margins problem, I keep forgetting that. So we need to probably, have this larger before we can go ahead and run that code. Okay. I run this entire chunk of code. I'll have to copy this down here. Uh-huh. No. Okay, it's come here, but why it is not? I'm unable to copy it properly. So, but this is the point of it. So it's got one column. Oh, that graph came and again vanished. I'm sorry. Okay. What I'll do is I'll just run it over here once again within this and get it a little bit more tight. Okay, control enter, and this is what we get. So it is basically one row and one column. Okay, so within one row and one column. No, 1 second. Yeah, so this. Whenever, sorry, I need to run this first, and I'll comment this at the end over here. Yeah, so this is the first chunk that we will run, and we will see what we get. So we have got 2 rows and 1 column, right? So 2 rows and 1 column. So the column is 1 and there are 2 rows, but this does not look very nice because the histograms are kind of squeezed vertically. So that is not correct. That is not what we want. So we decide, okay, fine, let's change this alignment and let's look at 1 row and 1 column. Yeah, so 1 row and 1 column. So this is, oh, sorry, this is 1 row and 2 columns actually. I should change this over here. 1 row and 2 columns. And then 2 rows and 2 columns. I'll again make this code slightly concise. Yeah. So this is what we have. Now, how can we end up seeing all of this together? So this entire piece together. So what we'll do is we'll quickly knit the HTML part of it, wherein the graphs should look slightly much better than the PDF. With visible eval execution halted, function described by calls anonymous. Okay, so line 599. So there's an error on line 599. I will fix this in front of you. I will not stop the video. We just go to line 599, and that described by is creating trouble. $5.99. Okay. This shouldn't be the case. I don't know how come it is saying there's a challenge here. Describe by, okay. Okay, now net to HTML. I think it is going through now. Things seem to be okay. So there was some. You saw something in the. There was another pop-up. Where is that pop-up gone? Okay. So anyway, so sometimes a table or something will pop up separately and will look extremely weird, but let's not bother about that. So this is the histogram that we saw, first histogram. Second, this is multiple histograms. This is 2 rows and 1 column. This is 1 row and 2 columns, slightly much better. And this is 2 rows and 2 columns, which is okay in case we want to show 4 plots together, but is not the ideal situation. I'll just take a screenshot of this and I'll save it for later reference. Slightly much better. So like this you can go ahead and arrange as to how your plots should show. This is really bad, this is not correct. These are okay, but then these are singular plots. So this is what it is. Fine, so perfectly fine. So what we'll do is we'll just let this be for now. We close this HTML net. And like this, we've also checked that our actual knitting of the R markdown or the HTML won't give us trouble by the end of this session. So kind of fixed whatever the challenge was. Okay. So coming down here. Now layout is another way of managing the layout of plots beyond the par function. The par is the simplest probably. Layout is also another option. Now the layout of is again a matrix by row, and the width is 4:1, height is 4:1. So let's basically what we'll do is we'll go ahead and run this to understand what is happening. Yeah, so this is what we get, the different layouts which are available to us. So this is layouts of individual plots. Okay, red, yellow, black, yellow. So what exactly is this? So DF1 date of invoice and DF1 sales, two things, sales price, two things we are basically plotting over here in red and yellow. Okay, so this one is what? Cost price. Cost price, black, column yellow. So there's another plot which has gone before this, which we did not. Yeah. This is the one. The first one. So the first one is this, which is row 914, 9114 that we can see over here that I have kind of highlighted. And running this gives us this particular plot. So the date of invoice and the sales price both have been plotted as a box plot. So the first one which got plotted has taken the red color, the next one has taken the yellow color. We can change this, so we can make this green and yellow if we want. Yeah, so we get to see green and yellow. The next one is the cost price, and the main column, the color is black for what, and what is yellow. So black is the color of this this title up here. If I were to make this blue or say red, just for argument's sake, we'll see that it has turned out to be red. But obviously a red label is not correct. And this is just our introduction to plotting. So we need not We are not getting into details as of now as to what is happening, for what reasons, and all that. This is just initial introduction to plots. Next is again what I did above. I think it's turned out to be the same thing, green and yellow. Though I have date of invoice and cost. Okay, I had sales price earlier. Now I have cost price. So again, nothing very fancy here. And this is the last one. Okay, so we are done with this. Moving ahead, scatter plots. So again, initial introduction to scatter plots. So we've gone ahead and created one. Uh, we have created one data set, and this is what the dataset's summary looks like. So it's got 11 variables, and out of those variables, uh, 11 variables, and this is how they're distributed: the min, the first quartile, the median, the mean, the third quartile, the max, for all those 11 variables. And we also want to look at this data set once and try and understand what this data set is all about. So let's just go ahead and first view this data set. So view with the capital V, and we go df underscore a1, df underscore a1, and there you have it. So which one of these is a factor? So this is numeric, this is numeric, 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 numeric. There has to be a factor somewhere. No factor variables here. Okay, the first one's a factor which has 38 levels. So there are different product names. Different product names are there. So products from 1 to 38, and then rest of them are all numeric, even though I would presume one or two of them to be factor. So this is range 0 and 1. So why would this not be a factor? Range 0 and 1, range 0 and 1 again, range 3 to 5, why would this not be a factor? Range 1 to 8. I would consider A8 to A11 to be factors, but R is not showing that, so I'll again have to check. I'll put a check over here. Check why not factor variables. Okay. Now, the summary we've already seen. So let's go and plot this. So let's have an initial plot of two of these columns. So we want uh, column 5 and column 6. So that is just to begin with. Then we'll go and see how we can change this and plot various other functions. Sorry, plot various other variables. So what I'll do is I'll use the plot space on the right side. Okay, so that's our first scatter plot, a very important plot, the scatter plot. So the values are designated by these points. So the blue points, or the blue small circles over here, are from one variable. The red ones are from another variable. So we've got two variables, that is from the df_a1 we've got a6 and a5. A5 because it was mentioned earlier, or rather mentioned before a6, has gone on to the oh my god, we've gone way up, and has gone onto the x-axis. So let's change this and see whether we can change it and do something else with it. Okay. Yeah, so we'll make this A6 and we'll make this A5 and copy this from here, paste it down here, and run. Perfect. So A5 and A6 have now swapped their places. Now, even though they have swapped their places, and we can look very carefully over here, here you have A5 on the x-axis and A6 on the y-axis, and now they have swapped. A5 has come on the y-axis, A6 on the x-axis, but the distribution looks quite similar. So basically what is happening is it's almost as if the points are clustered up here and then they're moving down here. Yeah, and where you see blue points, you also see red points. Where you see red points, you also see blue points, which means they are correlated. So you need to consider this term very carefully. Correlated. And how? Correlated how? So what is, so they have a correlation amongst them, but what is that correlation? So the correlation is that when the values of one particular variable, whether it is a5 or a6, whichever one, when the values of one variable increase, the values of the other variable decrease. That means there is a negative correlation. Very important to understand. When the values of one variable increase, so increase for the one on the x-axis is how? Starting at 3.0 towards 5. So that is the increase. So as this is increasing, the values being plotted here for the other variable, I am considering, okay, now I don't know which one is red and which one is blue. So the one which gets plotted first, or the one which gets plotted on the x-axis, yeah, the one on the one on the x-axis or on the y-axis. The one on the y-axis is red and the other one is blue. So let me make this green. Let's change this to green and check. Yeah. So that means A5 is green, which is on the y-axis. Yeah. And A6 is red, which is on the x-axis. So as we see that values of this are increasing over a period of time, we can see these values are reducing because it has come down to 3 over here. So this is a negative correlation. I will call them highly correlated because there is not a very large sample size, and also there is a negative correlation. So this is the first, the very first plot for a scatter plot, and we are looking at correlation over here, and we are looking at negative correlation between these two variables. Okay, that is one. So it's a, so now just reading out what is written here. It's a synthetic simulated data set. Synthetic simulated means that I've gone ahead and created this data set. It is not coming from some real world observations, or maybe it's coming from some real world observations and I've tweaked it a little. So that is what usually is done. You pick up a data set which has got some real world observations and you tweak it a little to create your own synthetic data set. So that is done often. Okay. As seen below, variables A1, A3, A5 and A7 double or decimal, double precision numeric values. So that double or stands for double precision numeric values, and x1 is equal to the varchar, or basically the character variable. All others are integers, so we've already kind of seen that. And quoting verbatim from Wiki, the scatter diagram. So what exactly is the scatter plot? You can go ahead and see that. If no dependent variable exists, either type of variable can be plotted on either axis, and a scatter plot will illustrate only the degree of correlation not causation between two variables. Very important three lines over here. Very, very important three lines over here. I'll again read them out. If no dependent variable exists, so we don't know whether a dependent variable exists in this particular relationship or not. So I'm presuming there is no dependent variable. Either type of variable can be plotted on either axis. So you can have any of the variables on x axis or on the y axis, and a scatter plot will illustrate only the degree of correlation. It is not necessarily causation between two variables. To understand causation, to even understand the first step of causation, we would want to get into some kind of simple linear regression. So the most common form of regression, the simple linear regression, is what we will want to get into in case we want to understand causation. So again, I've kind of highlighted that, saying very, very important, not causation. So how do we ascertain causation? So we shall see that within this text soon. So that is going to be simple linear regression. Again, using the par function to create these plots and plotting them in a certain manner. Here we get to see this negative correlation, which means when these values on the x-axis increase in the sense increase on their scale, move from 10 to 30, the values over here decrease. So the initial values are somewhere about, say, 500, they come down to 300, and then they come down to 100, right? So the last four values, that is these four red dots that we see, I'm looking at the first plot, that is plot A. Within the within the box, within the square brackets, we have negative underscore core, that is negative correlation. And let me, yeah, so this is plot A that I am looking at, and so this is a plot which shows negative correlation. Then plot B, slight positive correlation. So slight positive correlation means that these points are not plotted very tight together. Over here, top right, you will see that that blue point, which is probably showing either 30 or 5.0, I'm not sure which one. So I'm not sure which one is A5 or A1 is green or blue, I'm not sure. So let me go and check first. So what is A5 and A1 over here? So A1 is blue. A1 is blue. That is line 956. Between the highlighted code, line 956. This one. So A1 is blue. Yeah. So this value of 30 which is shown here for this particular element of the A1 data frames columnar vector is corresponding to values between 4 and 4.5 for A5, which are again values on the higher end or the highest values for A5 being plotted on the y-axis. But still they are not so close together like we can see these values over here in plot A, which are much more close together. So we say slightly positive correlation, which means when these values increase, those values also increase, but they don't necessarily increase in the same, they're not so tightly correlated to each other. Okay. Then comes negative correlation. At plot C, again negative correlation, a similar distribution as seen in plot A. So we just call it, we can say it is almost the same. And again, plot D. Plot D is inconclusive. So we don't see a high degree of correlation between A1 and A7. What I could also do is I'll probably just do that in the next video. We will go ahead and create core plots for all of these variables together. So we'll see the correlation between um, the first variable and all the rest of the 10 variables. So we will have a plot which will show simultaneous correlation between 11 by 11 variables. So let's do that. So that is one thing which is quite my favorite and is also statistically speaking very important. Thank you.